Yeah, it closed down automatically. But if you need, I'll open it up again. All right, so we've got this. How many electrons being shared? Are they being shared equally or unequally? They are being shared equally. What kind of bond is this? Is it a polar covalent or a non-polar covalent? Non-polar covalent.
Symmetry and non is symmetry too.
Okay, so the word non is symmetric, and that means on both sides here it's exactly the same. So this is a non-polar covalent bond. It's also a non-polar molecule because there's only one bond in that molecule. All right, oxygen. How many electrons are being shared between two oxygen atoms? Two pairs, thank you. Two pairs are being shared. And what is that called? What kind of bond is that?
Something. A bed molecule. No, that's water. A double.
Is a double covalent bond. Is it polar or nonpolar? It is also nonpolar. So it's a nonpolar double covalent bond. Okay, you can also draw it like this. Why did I put these little dots kind of looking like that instead of on the top and the side?
It's the degrees.
The degrees, right? So if we have, I don't know where my red pen is. It's red. Okay, if we were to look at the electron geometry of this, we would see that each of these is 120 degrees between them. Okay, and what would the shape of this electron geometry be? Yeah, triangle. It'd be trigonal. Okay, what's the shape of the molecule? The molecule would, I don't know what.
Wouldn't it be like the 1 6 plus 2?
Yep. It would be linear. So this is a linear molecule.
Oh, I literally had that.
You did. Okay. It's a linear molecule, but the electron geometry around that oxygen is trigonal. And the electron geometry around this oxygen is trigonal. That's not Regents level. That's higher up. Okay. But the shape of the molecule is Regents level. Okay. What about if you had N2 with 3 lines? How many electrons being shared? 6 electrons being shared. Okay, this is also a non-polar covalent bond. It's a non-polar molecule. Let me put the rest of the electrons on there. What else do we need to know about that? 3 pairs or 6 electrons shared. Okay. Then we did NH3. What does it look like? It is trigonal. Did we talk about whether it's trigonal pyramid or trigonal planar? Yeah. Okay. Do you want to take a guess which one this one's going to be? It is the pyramid. This is trigonal pyramid because what happens is these electrons are actually taking up room. Okay? Even though there's nothing bonded up here, they are taking up room, so all of these hydrogens are out. What's the electron geometry? No. The molecular geometry is trigonal. The molecule is a triangle. What is the electron geometry? You guys understand the difference between molecular geometry and electron geometry? Maddie's looking at me like I'm crazy. Yep, the electron geometry there's 4 electron sites. This is a non-bonding pair. And these are bonding pairs. Okay, but there's still 4 electron sites around that central atom. So the electron geometry is tetrahedral. But the molecular geometry, because there's nothing here, the molecule is trigonal. You see the difference? Okay. So this is a trigonal molecule. And again, they are only going to ask you about the molecular geometry at the Regents level. But if you go to Mr. Tahini's class next year or the year after, you're going to have to worry about electron geometry versus molecular geometry. So at least you've heard it before, even if you don't 100% understand it. Okay? All right. Let's do CH4, right? How many bonds can a carbon make?
4.
4. It has 4 sites where it can bond. I think we're going to listen to a podcast tomorrow.
What? I have no more pencils.
Oh my God, what's a girl to do? Okay, so in each one of these sites, you can form a bond. There's no such thing as a quadruple covalent bond. So this carbon is going to need to make 4 bonds. And what will happen, let's do purple now, is a hydrogen will come in and bond here, 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 and here. Okay. So we could draw it simply with 4 lines out of it that will show you the 4 H's. Just like that. That's the same as this, except it's written a little bit less messy. Okay. What's the molecular geometry? What's the shape of this molecule? Tetrahedral.
I knew that.
The electron geometry is exactly the same. Okay. Is this bond, let's do this. This bond right here, is that a polar bond or a nonpolar bond? It is a polar bond. Now, the molecule itself, is the molecule polar or nonpolar? Nonpolar, because it is symmetric. So again, we have symmetric, nonpolar, asymmetric, polar. This is all just review of what we did last week. And we're going to draw some more complicated ones today. Okay, and SNAP works for the bonds and it works for the molecule as well. Okay, if you look at this bond right here, it is asymmetric. The carbon and the hydrogen are not sharing their electrons equally. Right? Who gets the bigger share, the carbon or the hydrogen? How do you know that?
I don't know, I guess. Am I right?
Yeah, you are right, but how do you know?
The carbon is like the whole.
Look at the electronegativities, and carbon's electronegativity is 2.6, and hydrogen is 2.2, so carbon gets a bigger share of those electrons. Yeah, I don't recommend it.
I actually really not good at guessing.
But I really don't recommend it. By guessing?
Yeah. Oh no, that's why I failed those, because I guessed like that.
I'm good at guessing though.
All right, let's do I did ammonia, I did CH4. Let's do carbon dioxide. Regents love this one. They love asking you to draw carbon dioxide. I don't know.
Is that a capital O?
Yep. Carbon dioxide. Okay. It is a PTQ. You like that? I made that up, PTQ.
I like that. I'm so proud of you.
Oh, yeah. You should be. All right. This is what we're going to do. We're going to do this one a little bit differently. Okay? You're going to watch. You're not going to draw anything. Do not draw anything, because it's going to get messy. No. Don't draw anything. All right. Carbon has 4 valence electrons. Yes, no? Okay. Oxygen has 6 valence electrons. Okay? And there's 2 oxygens. This is the way you're supposed to draw every covalent compound, but we're not going to do that because it gets very complicated and I don't want you to, only the ones that, let's just do this. So total, 6 plus 6 is 12 plus 4 more means I have 16 electrons total, right? Okay. Which means I have 8 pairs of electrons. 1, 2, 3, 4, 5, 7, 8. Okay, there's my 8 pairs of electrons. So imagine I strip all of the electrons away from these guys, and I make pairs. So I have 16 electrons, which is 8 pairs. Okay? Now, what I'm going to do is I'm going to take the carbon, which is the most electronegative element, and I am going to glue the oxygens to that carbon. I'm sorry. Carbon is 2.2. What's oxygen? Oxygen is more electronegative than. Oxygen is more electronegative, isn't it? 3.2? 3.4, and carbon is 2.6. Okay, so we're going to put the least electronegative, the one that's the single, you always put in the middle. And then we're going to glue those oxygens on. And each one of those pairs of electrons is a piece of glue or tape or whatever. Okay, so that's what it looks like. These two oxygens are the same. Okay? Everybody good so far? Now, we know that oxygen is more electronegative than carbon. We just looked them up. So the oxygen, I used 2 pairs of electrons already. The oxygen is going to get the electrons next. Oxygen is stronger than carbon. So oxygen gets the electrons next. So I'm going to complete this oxygen's octet. That used up 3 more pairs of electrons. You with me? Where did the other 3 pairs of electrons go? On the other oxygen. Okay, now we have no more electrons left. Everybody agrees? Let's take a look. Is this oxygen stable? Happy? Okay. This oxygen is happy. Carbon, wah, 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 not happy. So we got a happy, we got a happy, we got a not so happy in the middle. Okay. So what happens in a situation like this is these electrons that are out here on this oxygen are going to shift to go between the carbon and the oxygen. One pair of them is going to shift. And when this pair goes in here, this is why I didn't want you to draw anything yet. Okay, it's going to look like that. Okay, I could have taken the top ones and shifted them, or the side ones and shifted them, whatever. I just took the bottom ones and shifted them over. And the same thing is going to happen over here. This pair of electrons is going to shift in. Now, that oxygen is happy. This carbon is happy. And this oxygen is happy. You see that? Okay. This carbon dioxide is a linear molecule. Dylan, you're making faces. You all right? Okay. It is a linear molecule because what will happen is you will have a double covalent bond on either side of this oxygen, and it will look like this when you are done. I'm going to color it in. I know. Look at that.
So pretty. I love highlighters.
I said that last week too. Okay, that's what a carbon dioxide looks like. Why is it linear?
Just because.
Just because.
Oxygen is linear.
No.
They all have the same amount.
They do. And so this electron geometry right here is 120, 120, 120, right? There's 3 spots around this carbon. And so these 2 non-bonding pairs of electrons are pushing everything this way. And these non-bonding pairs of electrons are pushing everything this way. There's nothing on this carbon, so what's the electron geometry of this carbon? What's the bond angle here? 180, thank you. And the bond angle down here is 180. You see that? Okay, because there is no non-bonding pairs of electrons on this carbon, then it just goes in two directions. So this is a linear molecule. Go ahead. This? These? No, it doesn't. Because you just know by looking at this, there's 3 electron domains. There's a domain here, there's a domain here, and there's a domain here. In this domain, you have 4 electrons, but there's 3 sites. Okay, so this is just drawn as a 2-dimensional. This is kind of trying to show you that it's 3-dimensional. Nope, there does not have to be 4 sites. Okay, let's look at the difference between this carbon dioxide and agua. Agua. You know agua. Okay, let's draw it the same way. Let's draw oxygen, has 6 valence electrons. Hydrogen has 1, and hydrogen has 1. 6, Catherine. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 total, which is a total of how many pairs? 1, 2.
Wait, did I count wrong?
No, I did. I counted wrong. Okay. 1, 2. I said 6, and then I drew 7. 1, 2, 3, 4, 5, 6. Okay. Now we got it. That means there are 4 pairs. Yes, no? Okay. 1, 2, 3, 4. What element goes in the middle? Oxygen goes in the middle. Okay. It's the element that there's only one of that's going to go in the middle. All right. Now, let's use these pairs and glue them onto this oxygen. So we're going to take one pair and glue it there. We're going to take another pair and glue it on here. Where do you want to glue it? Top, right, bottom? You want to go over here? Okay. So I used 2. Now, let's check for happiness. Is this hydrogen happy?
Yes, it is. Because it's a duet. Are you happy?
Okay. This hydrogen, I'm happy. I'm happy because I'm with you guys.
Aww.
There you go. That's happy. Is this oxygen happy? No. So what are we going to do with the rest of these 4? Okay. So, we drew water the other day. Does water look like this? No, it does not look like this. However, look at the geometry around this oxygen. It's tetrahedral electron geometry, yes? Okay? But there is nothing bonded here, and there is nothing bonded here. I just gotta get my mind. Alright, so tetrahedral geometry is gonna look like this.
Got it. Okay. We're gonna hide our elephant in the shop every day for you guys.
I love not being able. Hold on, let me shut this video off so that. I told you to just draw the oxygen. Remember I said do this? Go around once, go around again. If you do it like that, then you can see that your hydrogens would go here. And it's easy, very easy to see the shape of this as bent. Okay? That's why I told you way back when, go around once, go around again. That will work for water. Water is a polar molecule It has polar covalent bonds. Polar bears swim in water, right? What else do we know about this? I just thought of something in my head, but it's bent. Thank you. Bent. Okay, it's a bent molecule. No, even though H2O looks very similar to CO2, why are their geometries different? Water has two non-bonding pairs of electrons. Carbon dioxide, on that carbon, do we have any non-bonding pairs of electrons pushing those oxygens down? No, and that's why this is 180 and this is 109.5. Okay? You feel me? Merry Christmas to you.
What do you want for Christmas?
All right, let's draw carbon tetrachloride you can do by yourself. Carbon dioxide I drew for you. Phosphorus trichloride. Phosphorus Cl3. Let's do this one together. Okay? Let's put a P. How many valence electrons does P get?
He is phosphorus.
It is 5. Okay? Chlorine gets 7. Okay, and how many chlorines are there? 3. So where are they going to go? Should we strip them all down and do them as pairs? Okay, so we got 3 chlorines. 3 times 7 is 21, plus these 5 is going to be 26, right? Which is 13 pairs. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We really don't need to do it like this, but we can. All right, so let's do P in the middle. Okay? Let's P in the middle. Let's glue the chlorines on. Doesn't matter where you glue them on. So let's put a chlorine, and a chlorine. That used up 3 pairs. Oh. Okay. Now, who gets the electrons next? The P or the Cl? Who's stronger? A Cl. So let's put 3 more pairs of electrons on this Cl. That used up 3. Am I going too fast? Or are you okay? Let's put 3 more on this Cl. Let's put 3 more on this Cl. I have 1 pair left. Where is it going? On the P. Check for happiness. Happy. Happy. I feel like Will Ferrell.
I love Will Ferrell.
Happy. What? And then happy. So everybody's happy. We don't have to shift anybody's electrons around to make anybody happy. Okay? What's the shape of this going to be? Electron geometry is tetrahedral. What's the shape of the molecule? Trigonal. It is trigonal. Okay? You have to understand the difference between electron geometry and molecular geometry. Electron geometry will not be asked on the Regents. It's always molecular geometry. But electron geometry helps us understand what the shape is going to be. This is going to be a trigonal molecule. And is it going to be trigonal planar or is it going to be trigonal pyramid? Pyramid. This electron domain right here is pushing these 3 guys down. So keep in mind again that it looks like this. Got 4 sites around your central atom. It's going to look like that. Okay? Here's the non-bonding pair of electrons. And remember, you can't see that. Oh, look, you can see my little watch. Look how cute it is. and then you've got 3, and they're pushing down, so they look like a little pyramid. See them? Losing my molecules. You're losing your molecules.
What do you want for Christmas?
Oh, I'm not ready to think about Christmas yet.
Are you cooking Thanksgiving dinner?
I am.
It's only 34. Are you a good cook?
No, it's debatable.
Your son is a good cook.
He is a good cooker. I call him my good cookie.
I'm a good cooker.
Let's do carbon monoxide. Carbon has 4 electrons. Oxygen has 6. That's 10 electrons total. So that's 5 pairs. Okay? Glue the carbon and the oxygen together with 1 pair. Who gets the electrons next? Oxygen. So he gets his octet completed. Bam, bam, bam. We got 1 set left. Who gets them? Carbon. Okay. Now when you check for happiness, is carbon happy? No. Oxygen is. So oxygen says, all right, I'm going to shift my electrons into the middle so we both can use them. Right? So first set gets shifted, and it looks like this. Do you see what just happened there? Am I done? No. So what has to happen next? Another set has to shift in. Yeah, oh my. So what kind of bond is there? So this is the first step. So what kind of bond is this now? It's not trigonal. Is that a triple covalent bond? Polar or nonpolar? Jill, think before you open your mouth. It is polar, okay, because it's 2 different elements. So this is a polar triple covalent bond. CS2. Yeah? There's trigonal planar and trigonal pyramid. But you only have to know trigonal. Okay, for Regents level, you just have to know trigonal. We'll do this one when we come back. Valence electrons. 4 valence electrons. And we got sulfur that has 6. So that means 12 plus 4 more, right? There's 2 sulfurs. I can draw both of them. Okay. 12 plus 4 is 16. So that's 8 pairs. I like to draw my pairs just so I can cross them off. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8. Carbon goes in the middle. We'll use a pair to glue a sulfur on. I'm going to glue the other sulfur up here, just to show you that it doesn't have to be in a straight line like that. Who gets the electrons next, sulfur or carbon? Who's stronger? Sulfur. Okay, so I'll use 3 pairs for, are they the same? Okay, then work from the outside in. Okay, and sulfur over here gets 3 pairs. All right, now I got a problem, don't I? Okay, so what's going to happen? Sulfur moves 2, and this sulfur moves 2. Okay, now carbon is going to have a double covalent bond and another double covalent bond. Looks exactly like carbon dioxide. All right, you want to try some on your own now?